in front of you, you kind of see an agenda for today. I'm going to ask that your camera's on, of course, as always. I appreciate that. Again, just a reminder, please stay in class till 11:15 unless you give me a heads up with an email that reasons maybe have an appointment or something else. So that's, just let me know, okay? Today's quiz, there are 11 questions on it. They're each worth 2 marks. Essentially, I guess I'm trying to make them worth less if you show me some work. Right? If it's only 10 marks, then each question is worth 10%. I'm trying to make them worth, in some ways, 5% each question, or each mark, pardon me. But again, to see part marks, I would need to see your work, and the only way to do that is through Equatio, okay? So if you can use that. Most of you did yesterday, and I appreciate it. It was nice to see your math work. Very, very important to me as a teacher, and it looked really good. So thank you. Number 4 on the agenda. When going through your assignments, there are 2 questions that are continuously, I would say, well, 95% of the students are getting it wrong for a couple reasons. So after today's class, I'll leave this open till about 4 p.m. You'll be able to go back in and redo only those 2 questions. I can actually see which ones you redo, so please do not go redo more. These 2 questions I will allow you to redo, and we'll discuss them right now in case you see them on tomorrow's quiz in some form. For question 14, if you're getting n equals 8, in other words, 8 rounds, maybe you're familiar with tournaments or brackets, and maybe you're not with sports. But when it comes to sports, it takes 2 teams to play a game, okay? So I'm trying to give you a hint here on this particular question. You need 2 teams to play a game. So first round is 128 teams. I hope you can see my screen. The next round is 64. A lot of you are using the last term as 1. Well, you can't have 1 team to play a game, okay? You need 2 teams. So your last round of games, or your last T value, is 2. It's not 1. You've already determined the winner at that point. So it is not 254 games. Or some of you might even, might be getting 257. I don't remember which number a lot of you are getting, okay? And that's because you have the wrong number of rounds in the tournament. It's not 8, okay? So you can go in and fix those. That's worth 2 marks if you want to. And question 16 was about a car. And it's very easy on this type of question to think 5 years means T5. Okay? So I'm going to draw a little picture for you. I don't remember the car's value. I think maybe it was 20,000. So today I bought a car at 20,000. I'm going to call that my T1. A year later, that's my T2. Year 2, year 3, year 4, and year 5. Well, you'll notice at this point, this is not T5. Okay? So time, we've got T1 the day I buy it. A year passes, that's now T2. And that affects the second part of the question as well, because if we get the wrong answer in the first part of the car's depreciation, we can't be right in the second part. So these 2 questions were worth 4 out of 24 marks. If you want to go in and change them, you'll have the ability to edit them. So you'll have to just delete your Equatio picture, put a new one in. If you don't change it by 4 p.m., then you live with the way it is, okay? It's your choice. So after today, I'll open it up and you can, I'll send you the link to edit it. Any questions there? I strongly encourage you when it comes to questions about years and time to draw yourself a little chart. Otherwise, we just jump to 5 years is T5, and that's not correct, okay? So in other words, this is T6 you're trying to find. Okay, we're going to jump into our very last concept before the new year. It is a geometric infinite series, it's called. It's a very short lesson. And it's also geometric. So this being geometric could also be seen on your quiz tomorrow, okay? So for geometric infinite series, we're gonna go through the notes. I'm giving you just a homework package on it with answers. It's not for marks, the geometric thing, because it's probably gonna be 1 or 2 questions on your quiz tomorrow. I've also sent you review packages if you want all that work to make sure you're ready for tomorrow's quiz, because learning at home is not the easiest at times. So you have review packages for 6.3, 6.3, 6.4, and 6.5 also in your Google stream, okay? Tomorrow's a quiz on 6.3, 6.4, 6.5. It's about 22 marks as well. Thursday we review, and Friday test, okay? All right, here we go. For today's last lesson, it is 6.5, geometric infinite series, okay? The word infinite means you never reach it. You go on forever, right? So there are 2 types of infinite series. And the idea of an infinite series is, does it approach a specific number? If I keep multiplying, will it come to the same number eventually or not? Or if I keep dividing, does it come close to a number such that it just stays very close to that number, okay? So for instance, on this one, when I look at R, and R is going to be the key for today's lesson, geometrically, what are we doing to go from here to here? Rodney, what are we doing?
Are we dividing by 3?
Are we from 4 to 12? Did I divide by 3, you think?
Oh, wait. Sorry, my
Or
thing
did I multiply by
3? I was on the next question. My thing zoomed in. You're multiplying by 3.
Oh, sorry, bud. Good, thank you. So, Rodney, if you think about this sequence, will it ever approach a number, or will it keep growing forever?
It'll just keep growing forever.
All right, so it continues to go on to infinity. And the symbol we use for infinity is like a little sideways 8 for this. So this series will never approach a number. It just keeps growing as I multiply by 3. Okay? This one, in some regard, if I was to do the sum of it, we are multiplying by -2. But at the same time, it goes like -2 plus 4. I'm at +2. Take away 8. Now I'm at -6. Add 16. I'm at +10. Add -32. Now I'm at -22. So this one continues to approach positive and negative infinity. It never really approaches a number. It just keeps growing negative. It keeps growing positive, depending where I am in the sequence. So it's not approaching a number, okay? The third type, which is more than likely on your quiz or test, is when I see a sequence flip-flopping between 2 numbers. So it goes from -7 to 0, to -7 to 0, -7 to 0. So this one is another type of an infinity series. It's not approaching a number. It approaches 2 numbers in some regards, 7 and -7. So it's not approaching 1, okay? All of those above, if they don't approach a number, they're called divergent. All of these above are divergent series. There's nothing to do. Mathematically, you're done. If they grow to infinity positive, if they grow to infinity negative, or if they flip-flop, they're divergent, you're done the question, okay? So you're determining today, are they divergent or not? And if they're not divergent, the other term is called convergent. In other words, they're converging to a number, typically 0, okay? So if we go to the next part, and I'm going from 270 to 190, what I'm actually doing is dividing by 3. And I divide by 3. And I divide by 3. And if I divide by 3, I get like 10 thirds. The number keeps getting smaller. And if I kept going, it's going to get so small, it's like adding 0. Okay? So at some point in time, this one is going to approach a number very, very small. It's not going to move, probably be in like the 300 range, maybe 330 range, because 270 plus 360, 390, 400. So it's going to stay very close to around, 410. Eventually, we're getting like so small of numbers, it's not going to move. Okay? Now, when we come to a ratio, into yesterday's lesson, I said to you, T2 divided by T1, and you're going to get this ugly looking decimal. Please do not use decimals as R's that don't terminate. In this particular question, your R needs to be 1/3. You're dividing by 3. So if the decimal doesn't terminate, don't use it. Okay, use the fraction. Same idea here. This one we're dividing by 2. Okay, looks like a -2. And so forth. And this one is going to be pretty close to reaching 0 at some point, because we're going like down to -0.2, back up 0.6, and eventually it's going to be pretty close to 0. When we approach a number, it's called convergent. And the only thing that matters today to tell you if it's convergent or not is what the heck is R. If I know the R, I can determine if it's divergent or convergent. Very simple from there. Let's go to the next page. All right, so you have a formula. And the formula is the sum of this infinite series, that little crazy little sideways 8, is done by term 1 subtract R. Okay? This only works for convergent. Again, if it's divergent, there's nothing to do. Just put an X, say no solutions, it's done. Okay? Well, here's the secret to knowing if it's convergent or not. If R is less than -1, greater than -1, so like 0.99999 negative, all the way to positive 0.99999. If it's in there, it's convergent. Any other R value makes it divergent. So if R is 1, that's divergent. And that would be, for instance, let's just back up a page. Okay? If I was to look at my R value here, it's -1. And that's why it's also divergent, because R was -1 here. Pardon me, a little r. Okay? If I look at this R value, it was -2. That's less than -1, so that makes it divergent. So you just got to look at the R to determine if it's divergent or not. When I look at these ones, R in this case was 1/3, or 0.3333. That's between -1 and +1. That's why it's convergent. This one was like 0.5 negative. That's between -1 and +1, convergent. So looking at the R will tell you if it's convergent or divergent. Okay, so I want you on example 1, I want you to determine the R value for me. Example 1 being 27 minus 9. What do you think R is? And I'm going to ask Ethan, if you're out there, Ethan, to tell me what R is in your mind.
I was actually just about to ask a question, what R was. Like, how do you, obviously I'm about to ask, how do you find it?
Okay, in Friday's lesson, I always said take a higher term and divide it by a lower term, provided they're consecutive, okay, Ethan? So in this particular case, I would probably do -9 being T2 divided by T1.
Okay, thank you.
Okay, so now that you're on the mic, what does my R equal? We want it in lowest terms.
I guess negative. I actually don't know, because I got like -0.3 repeated.
I know, so that's a problem. So what should I call it? If I get a repeating decimal, I should know its fraction, Ethan. So divide both of those terms by 9. What do we get?
1/3, like -1/3, I guess.
There, that's a better R. We don't want to use
Yeah.
this one, ladies and gentlemen, because it doesn't terminate. So in this particular question, we'll have to use -1/3. Okay, so Mary, knowing what my R value is that between -1 and +1?
Sorry, can you repeat that?
So knowing my R value,
Mm-hmm.
is that R value between -1 and +1?
Yes, because it's negative.
Yes, so is it
0.3.
convergent or divergent? Pardon me?
Convergent?
Yeah, it's convergent because, like Ethan told us on our calculator, that's between -1 and +1. So this is a convergent problem. I'd like you to go use the formula, please. See what this series tends to come to. What number does it sort of add up to? So the formula is above. I don't think you see it on my screen. I have to bring it down. S with a sideways infinity sign. We have our T1. 1 minus 1/3, ladies and gentlemen. Now you need to solve that. Now, in my world of math, I do not like vertical division. So I would probably be tempted to say 27 divided by 4/3. Okay? And I can leave it as a fraction. Because remember, we got to do the reciprocal, which is 27 times 3/4. And that's 81/4, I believe. I can leave it like that, or decimal leaves me with 20 1/4 or 20.25. So this series is approaching the number 20.25 and it won't really get away from it. No matter how many times I keep dividing by 3, eventually that number is so small that I stay around 20.25. Okay? All right, I would like you to determine R value for the next example. What is it? And I'll ask Caitlin to tell me what it is.
It would be -2.
All right, Caitlin, awesome. So -8 divided by 4, she gets -2. So Caitlin, is this number between -1 and +1 or not?
No.
So what does that mean to you? Is it convergent or divergent?
Divergent.
Good. Is there anything to do, Caitlin, or are we done?
We're done.
We're done. Once we know it's divergent, there's nothing I can do because this answer approaches infinity or negative infinity. I can't get a sum. All right, question 3. This is a great question. I'd like you to try to figure out R. Who's out there? I'm going to ask Aaliyah. I see your face in my screen. What do you come up with R on that problem?
0.5 or 1/2.
Good job. Now, Aaliyah, could I use 0.5 or could I not use it?
You could use it if you wanted.
Yeah, very good. Okay, so using it, go solve. Oh, so Aaliyah, is this convergent or divergent, this problem?
It's convergent.
All right, so we can use the formula. Go solve the sum of this ugly looking geometric fraction. Who else is on my screen? Emily, I see you there. When you solve this, Emily, what does S infinity approach?
Would it be 1?
It is 1. Okay, and it's kind of a cool question. If you look at the diagram to the left, it's representing the sequence. 1/2 becomes 1/4, 1/4 becomes 1/8, 1/8 became 1/16, and it comes to a point where this piece of paper, or I keep cutting, it gets so small, I can't even see it. And altogether, it makes one sheet of paper, if you want to call it that. Adding those fractions together gets to a point of 1 because this corner gets so small, I can't even see it being cut anymore. So this all approaches the number 1. All right, last question. You determine if it's convergent, divergent, and if it's convergent, solve it. I think I see Preston on my screen. So Preston, I'm going to ask you to tell me what you come up with are, and then if it's divergent or convergent.
Sorry, are you asking me what R is?
Yeah, we'll start there.
R is equal to 2.
Awesome, Preston. So then, is this problem convergent or divergent?
I think you're going divergent.
And why do you think that?
Because it can go on.
Yeah, you're right. But you're right, Preston. It does go on. It's growing. But again, it's not between -1 and 1. If I'm between those two numbers, I'm convergent. So is 2 between those two numbers?
No.
No. So that's why it's divergent. So again, all ladies and gentlemen, is I'm looking for is R between those two numbers. If it is, it's convergent. If it's outside of that range, it's divergent and there's nothing to do. That's it. You've learned everything on sequences and series. There's a homework package on this with answers. It's not for marks, but again, you will see a couple questions on tomorrow's quiz because this is geometric. It's growing by multiplication or division, okay? The next part I'm going to do is put your quiz on. Now, the quiz for today, you can have formulas beside you. I don't care if you write them or if you have them somewhere. You're looking at 2 formulas. Tn equals T1 plus D n minus 1. Okay. Sn equals n over 2 T1 plus Tn. You can write them down wherever you need. And the second one, Sn equals n over 2 T1 plus D n minus 1. Those are the only 3 you should need for today's quiz. There's nothing outside of that because those were arithmetic, okay? And it's a little sloppy out there, so make sure you have it written clean for you. Typically square brackets here. Okay, so there's 11 questions on it. I expect you to be in session here till 11:15. There's lots of work if you finish the quiz sooner. You can do the review packages. You should be doing your 6.5 homework before the review packages, and then we call it the day. Any questions? All right, let me open up the quiz and send it to you shortly here. Oh, remember, you can redo those 2 questions. I'll send you that link too later here as you're doing your quiz.